descriptive language is one like SQL where you say what you describe what you want, but not how to get it. This comes up every single day, every single time. It's an in-memory data structure that keeps the data sorted to make compaction and merging easier. Why is it not going up? Do you see this? It literally never goes up. LSM tree, log, structured, merge tree. Log, structured, merge tree, yeah. Web service is any service that uses HTTP, I think, as its communication, for its communication. A server exposes a service, and a user connects to a server. A client connects to a server to access a service. Retries, multiple consumers, abstraction of the end result, acts as a buffer, decouple some stuff. Horizontal scaling. Horizontal scaling. Many smaller many machines. Instead of getting bigger machines, you add more machines. Yeah. Oh, this is when the order that the data is written, when you guarantee that the order the data is written in is the order that it'll be read in. Multi-leader replication. Google Docs. Offline access to like a calendar app. Multi-regional databases. When in a multi-leader setup, when the same record is updated in both leaders at the same time. Is the path of communication describes, I'm not sure, the communication paths, the path of communication I said, along which writes are propagated from one node to another. Just realized. Oh, it's on top. Cool. A few ways to resolve conflicts. Avoid them altogether. Most recent write wins, I think. You can concatenate the data, or you can prompt the user to resolve it. So multi-leader lets you're more resilient to data center outages and network outages, in general network outages, and writes can happen faster. You can service, I guess not writes necessarily can happen faster, but you can service different regions much faster because you're physically closer. Cons would be it's really complicated and it's hard to manage. Conflict resolution, that's right. Replication lag is the time between when you write to the leader and when it's reflected in the followers, because you read from the followers. And this can result in, like, you successfully write, but it looks like you did not because you don't see the data reflected. Read repair is when you read a record, it can result in a write because you read from our many readers. No, you read from all readers. And then once you have a quorum, you can then update any readers that had a differing value. Dynamo style replication logic is when you write to all instances, and you only need n many to succeed to consider it successful. You also have to read from all instances and reach a quorum to find out what data you want. I think I've just described this like 2 or 3 times. Basically, n divided by 2 plus 1 needs to be reached to consider it successful. If there are n replicas, is when, if there are n replicas, each write must be confirmed by W nodes and reads by R nodes. Quorum is W plus R greater than n. Anti-entropy repair. In a dynamo style DP, you have a background process that literally is going through and checking for either missing or non-quorum records in replicas and updating values when necessary. If you don't have this and nothing is updated and the specific value isn't read for a long time, you miss out. You're less durable. Cool. So something I wanted to do last time is, let's see, how could I do this? So something I could do super easily, right, is if I open this folder, let's see. If I open DDIA, yeah. Okay, here, hold on. So code, file, new window, open, Obsidian, Vault, DDIA, open. Yes, I trust the authors. Okay, so this will be interesting. So it's all markdown. And now, if I open ChatGPT um, to my DDIA. Let's review. Um, Okay, so I added some instructions here. This will be interesting. This will make this session way more interesting too. Um, so I added some instructions. So first thing, let's bring back VS Code. All right, basically what I did is I just opened. Um, I was gonna look into getting a plugin for Obsidian to connect ChatGPT. Too complicated. What I can do right now is I can open the Obsidian folders in VS Code, and this already has a plugin, like it can connect. So it has the PDF of the book, and now it has all my notes and flashcards. So let's now add, not this, what? Oh, okay, so I need to close maybe this one. All right, so now I have this one open. Well, I have this open, but I don't. Let's go to, where am I? I'm in replication. So let's open replication here. Let's um, okay. I got distracted, but okay. So let's. Okay. Where am I at? Actually, here. Let's go back to chapter 4 first. Okay. I've taken notes on this chapter, and even created. Um, Because field tags in schema evolution, because fields are mapped to tags instead of names, property names are arbitrary and can be changed. Once deployed, though, certain things cannot be changed. The field tags must always have the same number of associated. Must always have the same number associated, as decoders will map that data to the specific tag. Required fields cannot be added after initialization in protocol buffers. Okay. Avro removes types from what's shipped. Clarify. Avro omits the schema from each individual record to save space, but the schema must be known out of band. Part of the file header or connection handshake. DDIA, the writer schema. Huh. Oh, interesting. No need to refine that. But could I add to let's do this too. Someone showed me this. There should be by the way, record flashcard. Let's see what this does here. Um, uh, um, let's see what happens here. I'm really interested to see what happens here. Okay, while that's going, I guess let's read some, right? We'll have this on the side. Why I think this, I guess maybe I'll voice over. So this could be helpful, right? It's like I read through the material, I make my own flashcards, and I've even learned all of these flashcards, and I've reviewed them many times. So now, since some of this stuff, right, the older material is further away from me now, it would be helpful if the cards were like 10 out of 10 primo. Like, you know, maybe it made more sense to me as the material was newer, but maybe I'm losing out on stuff. So I'm wondering if this will provide like a big boost. Huh. So this was a super annoying read right here. And what part of Obsidian am I in? Let's see. Limitations of quorum consistency, and then quorums. That's right, I had just written about this. The quorum condition, W plus R is greater than N, allows the system to tolerate unavailable nodes as follows. If W is less than N, we can still process writes if a node is unavailable. If R is less than N, we can still process reads if a node is unavailable. With N equals 3, W equals 2, R equals 2, we can tolerate one available node. With N equals 5, 2 available nodes. Normally, reads and writes are always sent to all N replicas in parallel. The parameters W and R determine how many nodes we wait for. i.e., how many of the n nodes need to report success before we consider the read or write to be successful. If fewer than the required W or R nodes are available, writes or reads return an error. Node could be unavailable for many reasons, because the node is down, crash, power down, error executing the operation. Can't write because the disk is full due to a network interruption between the client and node, or for any number of other reasons. We only care whether the node returned a successful response and don't need to distinguish between different kind of faults. I want to know what's happening with this thing. Oh my gosh, it's still going? What? That's crazy. Wozniaks? Memriz. Huh. Alright, so basically Hmm. Oh, bro, what is this? Okay. Close deletions. Okay. Oh my goodness. I mean, this is literally like giving me a paragraph. Alright, so when flashcards, I guess, suck, but the good news is that we could start doing better. Right? Next time. Interesting.